Okay, question 11 is the last one I'll go through, unless if you email me, preferably, or in the event that you don't email me, put on show my homework, and I'll go through any more questions. Okay, these are by far and away the most difficult ones, and they're slightly higher level topic, yeah? So, because this involves 3D shapes. A, B, C, D, E, F, G, H is a cuboid. The length AB, this length here, is 7.3 centimeters. The length CH is 8.1 centimeters. And the angle B to C to A is equal to 48. I'll label all these on in a second. I'm just going to talk you through my thinking, yeah? Right, but I don't actually know what the question's asked me yet. Find the size of the angle between AH, so in this case, if I wanted to, I could even draw that line. So AH and the plane ABCD. ABCD just means that bit at the bottom, yeah, that rectangular bit at the bottom. So if you're confused, the bit that I'm talking about is this bit here. I'll colour that in. This is the plane, yeah? In order to solve this problem, I need this length, this diagonal length through here, and this height up here. Because then what I'm going to make is a right angle triangle. The pen here. And it will enable me to work out the size of the angle between AH, which is essentially this angle here, and the plane ABCD. Okay, right. So that angle there is what I want. Okay, thinking. Obviously, you need to use the information that they've given me. Yeah, so that's what I'm going to do now. I'm going to try and use that information that they've given me. So that information they gave me was they told me that this length here was 7.3 centimeters. Okay, so if this length here is 7.3 centimeters, okay, and it tells me that the angle B to C to A, B to C to A is equal to 48 degrees. Right, that looks really confusing. So let's just put all these things together. If I can do that. In fact, I'll tell you what I'll do. I'll draw what is essentially this triangle underneath. So that length across there is B to A. This length is B to C. And this length here is C to A. Let me label that so you got it nice and clear, yeah? This is a difficult question, no doubt about it. That's why I'll go nice and slow. So this is A, this is B, and this is C. It's difficult to picture it because it's a 3D shape, obviously. But essentially, that will give me a right angle here, yeah? A right angle here, right angle here. Fill in the information that we have. AB is 7.3 centimeters. 7.3 centimeters. CH, oh, well, this bit doesn't concern CH, so I'll leave that off this diagram for the moment. Angle BCA, B to C to A equals 48 degrees. This angle here is 48 degrees. Okay, right. I want this length, A to C, this diagonal length here. I don't know what that is. I'm just going to call it X. Right. I have this triangle, which is a right angle triangle. I have an angle and a length. Therefore, I know that I'm going to use SOHCAHTOA. Okay, this is my angle. This is my opposite side because it's the one facing it. This is my longest side. So this is my hypotenuse. This would be my adjacent. I could label that on. In fact, why don't I just label that on? Right. What do I have? What do I want? This is what I have. This is what I want. Let's think about our angle rules. Let's just write out SOHCAHTOA. Right, I want something with O and H. The final two things are O and H. No, no, yes. This is the one that I want. Write out my angle rule. This one tells us sine theta, or sine of my angle. I always write out the rule first, is equal to opposite over hypotenuse. Fill in the information I have. Sine 48 excuse me, equals opposite, which is 7.3, over h, which in this case I've called x. This is one of these fiddly ones again, just like we had a moment ago. So x is my denominator. In the event that x is my denominator, I'm going to multiply by x first. X times sine 48, we're going to write x sine 48 equals 7.3 divided by x times by x is just going to leave me with 7.3. X times sine 48 equals 7.3. So let me just divide by sine 48 on both sides. Okay, sine 48 divided by sine 48 is just going to leave me with x here. This cancels with this, equals 7.3 divided by sine 48. All right, don't know what that is. Let me just plug it into my calculator now. So 7.3 divided by sine 48 is equal to, I'm going to leave it to 3 decimal places so I don't make don't have a rounding error at the end. So that gives me 9.823. Right. Just going to make this a bit smaller. And let's just plonk it underneath here, yeah. Right, so sorry if this is a little bit small. So what I'm now going to do, so I don't get confused, I'm just going to get rid of this one here and this one here. So I've worked out that pink length there, which is, what did we work it out to be? Was 9.823. 9.823. This length across the bottom was 9.823. Okay, right. I'm going to draw this triangle that I've drawn in black here. Right, let's label the things that I have. So I know that point there was A. This point up here is called H. And this point here was called C. This is a right angled triangle. That length across the bottom there is what we just worked out here, was 9.823. Now, if we remember back to our question, it told us that CH, i.e. this distance here, is 8.1 centimeters. Right, knowing that that is the case, sorry, I'm just going to get rid of centimeters. Very difficult to write with a mouse. So 8.1. And that was 9.823. Right, we're nearing the end of this now. So find the size of the angle between AH, which is that length here, and the plane ABCD, so that bit at the bottom. So that's basically saying work out this angle here, this angle. Call unknown angles theta. Right. Label. This is opposite the angle. This is my longest side, my hypotenuse, and this is therefore my adjacent. What do I have? In this case, I'm working out an angle, but the same thing applies. So I have an O and I have the A. Okay, well, angle rule concerns O and A. So if I list out SOHCAHTOA again, TOA, TOA, OA. Okay, so this one that I want is tan. Tan theta equals opposite over adjacent. Tan theta equals opposite was 8.1 over adjacent, which is 9.823. This is where I've left that to 3 decimal places, so I won't get a rounding error now. Now the inverse operation of tan of an angle is inverse tan. Yeah, so I'm going to do that in green to show what's going on. So when I do inverse tan of something, or tan to the -1, as a lot of students say, that means that the tan and the inverse tan are going to cancel, leaving me the angle theta, which is what I want. I therefore have to do inverse tan on this side of 8.1 over 9.823. So all I need to do now is plug that into my calculator. What did it want it to again? 1 decimal place. Right, here we go. Shift tan will give me inverse tan, and then I'm doing 8.1 divided by 9.823, close bracket, 39.508. So to 1 decimal place is going to be 39.5 degrees. Hopefully that helps slightly, guys. I know it's maybe not the best explanation I've ever done because it's very difficult to explain these things. Please email me in the event that you'd like me to discuss this further or do more examples. Thank you. Bye.